Dear students, today's session I'll be teaching two important blocks in a DC power supply. One is a rectifier and the other one is a filter circuit. We know the function of a rectifier. So rectifier converts AC to pulsating DC. So a rectifier is broadly categorized into two types. One is half wave rectifier, the other one is full wave rectifier. So in a half wave rectifier, only if you have taken the input like this, only one half of the input signal, that is either positive half cycle or the negative half cycle, is been rectified. But in a full wave rectifier, both the half cycle, that is either during the positive half cycle as well as during the negative half cycle, the output is obtained. So we are getting the output waveform for a full wave rectifier like this. There are two types of full wave rectifier. One is center tap full wave rectifier and the other one is bridge rectifier. So in our syllabus, we have to study only bridge rectifier. So this is the circuit diagram for a bridge rectifier. So in this setup, a transformer is used at the input side to step down the primary voltage, that is the voltage from AC mains. And the secondary of the transformer is connected to 4 diodes, which is in the form of a bridge. That is why it is known as a bridge rectifier. Now let us see the working of a full wave bridge rectifier. Case 1. So during the positive half cycle of the input signal, the polarity of the voltage during the positive half cycle of the input signal, the polarity of the voltage on the transformer secondary is as indicated like this. During the positive half cycle, the polarity is indicated like this. Hence, diode D1 and D2 forward bias, or I can say that diode D1 and D2 goes into the conducting state. Similarly, diode D3 and D4 goes on to the off state, or I can say that reverse biased condition. So forward biased condition, it is acting as a short circuit. Reverse biased condition, it is acting as an open circuit. Therefore, the current flows through the secondary winding, diode D1, load resistor RL and diode D2. So we'll get a flow like this, current flow like this. So for during the positive half cycle, we'll obtain an output voltage developed across the load resistor RL. Now let us consider the case 2. During the negative half cycle, the polarity of the voltage on the transformer secondary is indicated like this. That is, it is just opposite for the previous case. Here, the diode D3 and D4 forward biased, D1 and D2 reverse biased. Hence, the current flows through the secondary winding, diode D3, load resistor RL and diode D4. So the current flow is indicated in the dashed line. In both half cycles, the current flows through the load resistor is in the same direction. For the positive like this, for the negative cycle it is also like this. So a voltage is developed across a load resistor. So we get an output voltage during both the half cycle. We get an output voltage during both the half cycle. I hope the working of bridge rectifier is clear to you. Now we'll learn PIV for a bridge rectifier. Let us understand what is PIV. PIV is the peak inverse voltage. It is the maximum reverse voltage developed across a diode during reverse bias condition. So again let us consider the bridge rectifier. So this condition I have shown for only for the positive half cycle. So as I have said, during the positive half cycle, diode D1 and D2 forward biased, or it is acting as a short circuit. At the same time, diode D3 and D4 reverse biased. Now in this diagram I have not shown it as an open circuit, since we have to find out the voltage developed across the reverse biased diode, that is D3 and D4. I have indicated the points, this point as A, here it is B, C and D. Since A and C is shorted, it is at the same point. Similarly, B and D is shorted, it is the same point. So the same diagram I have redrawn like this. We can redraw like this. Here, for the positive cycle, D1 and D2 forward biased, D3 and D4 reverse biased. So I have not shown the reverse biasing condition. So we have to find out PIV is a voltage which is developing across a reverse biased diode. That means developed across either D3 or D4. So from this it is very clear that it is the secondary voltage. So for a bridge rectifier, PIV is nothing. PIV is the voltage VM. That is the voltage across the secondary. Therefore, PIV for a bridge rectifier is equal to VM. Thank you.